Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Okay, hello everyone. Thanks for joining us today in another session of this Fabric and AI Learning Hackathon. So today we are going to talk about PostgreSQL, that is this really well-known open source database. I'm Ismael Mejia. I'm a senior cloud advocate and part of the group creating this hackathon project and these sessions. And let me introduce Silvano. Silvano, please.
Yeah, thanks, Ismael. My name is Silvano Coriani. I work in the Azure Postgres team as a product manager.
Okay, perfect. Just before we start with the session content, well, I just want to remind everyone, well, that we're running this program. Now the deadline to complete the AI Skills Challenge is over. That was some days ago. And we are now waiting for the submissions. We have exactly 1 week from now on to submit the projects. We will have a session where we talk again in details about the submission process. And well, it's up to you guys. You have and girls, you have 1 week more to work on everything. So there will still things to learn today and with the upcoming sessions. Just want to remember everyone, well, yesterday we have a session about Cosmos DB. We are now focusing more on databases and how they integrate with AI and with Fabric, of course. Today we're going to talk about Azure database for PostgreSQL. And there is one last session where we're going to talk about the Fabric's data warehouse and how do you build AI solutions with it. So, well, you can join this for the next 2 days and you will have more things to see. So now, please welcome Silvano, who is going to talk to us about all the cool, nice things that Postgres has now for AI and in relation with Fabric.
Thanks a lot, Ismael. And again, welcome, folks. In the next 45 minutes or so, we're going to talk about some of the latest innovations and updates that we have been introducing for Azure Database for Postgres, with a flavor of more kind of application developers, but also with some interesting aspects regarding data professionals and DBAs in general. I mean, Postgres needs no kind of introduction, right? So over the last few years has kind of grown in terms of popularity and adoption. And right now it is also kind of extending its lead compared to other relational database technologies in the market. And Microsoft is actually investing a lot in Postgres. This is may not be the kind of most known subject in the industry, but we are contributing to the Postgres OSS code base for Postgres 17, which has been just released. There have been a lot of areas of contribution, starting from the query planner to a bunch of IOs improvements. And you can find this on in this particular URL that is copied here, aka.ms/blog pg@Microsoft. But we are also contributing to the Postgres community with conferences and content and so on, and through the well-known Citus open source extension for scaling out and sharding Postgres databases as well. But our primary focus is, of course, around providing a fully managed database service with Azure Database for Postgres, the flexible server, which is our kind of main service here. And the idea for us is to take all the good stuff that Postgres is providing, the Postgres engine around extensibility, the JSON support, the rich kind of indexing and such, and to actually wrap them around some kind of enterprise level capabilities spanning from security, performance, availability, and AI integration, of course, which is getting a lot more popular in kind of many database environments. So Azure Database for Postgres today is an enterprise-ready service which is adopting many of the very famous kind of Azure security and availability technologies. We do support intra-ID authentication, both kind of virtual networks and private endpoints for network security, data encryption at different levels, and also availability and performance across the board. And a lot of large kind of corporations and enterprises are actually selecting Postgres for running mission-critical apps. If we, to just describe quickly our architecture for the Azure Database for Postgres flexible server offering, we are a Linux-based service. Postgres actually runs better on Linux compared than other operating systems. So when you deploy, you create a new instance, we get a brand new kind of Linux, isolated Linux VM deployed. We deploy our kind of Postgres image in a container on that VM, and we attach our premium storage layer for data and log files, which is basically making up our flexible server instance. And then that instance is deployed on a given availability zone so that your applications running in VMs or running in AKS, Kubernetes, our app service in Azure can get minimal latency in connecting to our database instance. But at the same time, as we support the full availability, we are storing backup files and such in a zone redundant storage, so that you can actually recover in a different availability zone, or as we will see, in a different region in case it's actually needed. Performance-wise, we do have a bunch of different service tiers, starting from our memory optimized service tier, which is providing up to 96 vCores and 8 gigabytes of RAM for each core. So it's pretty optimized for high intensive and best performance workloads. Our general purpose, which is reducing the amount of RAM per core to 4 gigabytes per core, and it's basically ready for most of the database workloads out there. We also provide a burstable service tier, which is very cost effective. You can scale it down to a few bucks per month, and it's ideal for development and testing new applications, right? And one characteristic that our service has is the ability to scale up and down the amount of cores and storage independently. And in storage, you can actually scale the total size of your storage subsystem or the IOPS independently. And this is, again, not common across all database services in the market. And we provide the ability to scale up and down with under 20 seconds of minimal kind of downtime during these scaling operations. And we do provide 99.99% availability for our service when you are deploying it across multiple availability zones. Right, so pretty interesting numbers from an infrastructure perspective. From a Postgres version perspective, we actually typically support the last 5 major versions. Right now, we just introduced Postgres 17, which was GA'd a few weeks ago, but we do support starting from Postgres 12 and above. Right? And one interesting thing is that the Azure Database for Postgres service is basically doing minor upgrade versions automatically during our regular maintenance cycles that we have. But you can also upgrade in place your existing instance from a major version to the next. in literally minutes, right? So the ability to test and validate new versions of Postgres is always available in Azure. As I was mentioning, Postgres is very famous for having this rich ecosystem of extensions. We are currently supporting more than 60 different extensions. We validate them, from a security and reliability perspective before enabling in our managed service. And some of them are actually quite interesting also for. And we will see that later on, the AI integrations with our database, like for example Azure AI, and such. But the interesting thing is that we are also maintaining, automatically all the versions that these different extensions are publishing over time. So going back to security, I mentioned Entra ID integration. Again, Azure Database for Postgres is the only Postgres offering in the market, which is supporting Entra ID identities for authenticating against the database. For those of you that are running in Azure already their applications, it's pretty easy to actually leverage things like system assigned managed identities and user assigned managed identities in your application tier to connect back to the database in a passwordless kind of manner. So you don't need to actually deal with password updates and such, right? We do support encryption at rest using customer-based or customer-managed keys, right? And we do protect the data at rest even if you don't provide your own keys. We do have a kind of service-managed encryption keys to actually encrypt data at rest for your databases. And we've offered a full kind of support for network isolation, starting from supporting VNet integration, so you can deploy your Postgres instance within a private VNet and then run your workload there, or you can leverage private endpoints to expose your database service into a specific VNet and make sure that no other kind of network addresses will be able to actually access your Postgres instance and make it secure. So another important enterprise ready capability is we do offer several flavors of high availability, actually. So we do offer 0.0 kind of RPO and basically no data loss when you deploy a hot standby secondary with synchronous replication in a different availability zone. Right, so this means that every new kind of transaction that the user is committing against the primary will be synchronously replicated and will only return back to the user once it's committed on the second. Right, and in this high availability mode for hot standby, we do provide automatic failover, so your application don't need to actually change application, a connection string or such. And if a failover is happening from primary to secondary, we are rebuilding, automatically the secondary HA instance to make sure that your data are always kind of protected. For more disaster recovery type of scenarios where you want to actually move outside of a certain region, we do offer the ability to create RAID replicas. So you can create one or more, up to 5 RAID replicas in different regions. We are using, in this case, asynchronous replication, of course, to make sure that latency is not a problem for your primary database when it's shipping data to the secondary. And you have actually the ability to create what we call virtual IPs. So basically, you can create an abstracted new kind of IP address, and you can actually switch from your primary to a secondary in a different region, if you like, for again a disaster recovery region in case something is impacting your primary region where you deploy your application. You can also promote read replica to a new as a new primary if you want, for example, to actually move your databases across regions. And that's a great technique because everything will be fully automated, and you will get a new copy of your system in a different region with a full kind of transactional consistency. And at the end of the process, you will be able to switch all your application workload to the new region. Of course, we also do provide geo-redundant backups, so you can store your backups in a geo-redundant region, and make sure that you have a paired Azure region where you can actually recover, use those backups to recover your system in case a disaster will hit your primary. And you can configure how long you want to retain your geo-redundant backups, or you can also pick up the long-term backup retention, where you have up to 10 years of kind of supported compliance by storing your long-term backups there. This is typically providing an RPO, so in case something goes wrong with your primary, you have like a 5-minute delay where you may potentially lose data in that case, but everything else will be fully managed by our storage tier, and you will be able to recover from a disaster in the new region. Okay, so from let's say more infrastructure perspective, you can actually deploy and provision a new setup based on Azure Database for Postgres using infrastructure as a code, as a technique. We support, we do provide a Terraform provider for this, for those of you who are familiar with Terraform as an open source AIC code. Or we do have support for Bicep, of course, our own DSL domain-specific language for declaring the deployment of Azure resources. Of course, we do support the ARM templates, and we provide a bunch of quick start templates for deploying Postgres in different configurations with availability and such. And we also do support Ansible for managing kind of declaratively your Postgres instances. A recent kind of project from Microsoft, you may be familiar with .NET Aspire as a new framework for deploying and managing your full stack applications from application code to other resources that will get deployed and managed from your own kind of application code. .NET Aspire actually does support Azure Database for Postgres natively and Postgres in general. Right? So that's another way for .NET developers and also for non.NET developers to actually orchestrate both local local development phase and inner cycle of creating, testing, and improving your apps. And then when you're ready, you can actually publish the whole application through using Bicep behind the scenes to your kind of Azure and cloud provider. So that's another interesting option that we have for orchestrating and deploying Azure Database in Azure Database for Postgres in Azure. So as I was saying, we are actually introducing some new capabilities in the platform. Some of them are unique to Azure. One of these is our index recommendation service, which is basically constantly analyzing your workload in Azure Database for Postgres, we do have a support for a query store type of capability, similar to what SQL Server has, where we are actually recording all the most executed queries and analyzing your workload. And based on this, we are actually determining what is the optimal level of indexing for your databases. So we do create new index recommendations, but we also provide drop index recommendations. In many cases, actually, some of the performance issues that your database may have are actually caused by too many indexes that have been created over time, over the years on a given database, and they are actually penalizing, for example, new insertions or row updates and so on because of the additional overhead to maintain those indexes. You can find in the deck a link to our documentation for how to actually configure and use index recommendations in a flexible server in Azure. Again, this is a pretty unique feature that we have on our end. Okay, so let's start digging a bit deeper into AI and how Azure Database for Postgres is providing some AI-specific capabilities, mainly in these three areas. One is support kind of native vector similarity searches through, we will see a pretty famous kind of extension that we have. Second, to be able to interact with our Azure AI capabilities in Azure, specifically our OpenAI services, but also the formerly known as Azure Cognitive Services, now Azure Language Services, to run a bunch of different workloads and use cases there. And last but not least, the integration with Copilot in Azure for helping out creating, designing and maintaining our Postgres installations in Azure. So vectors are super important for our databases, but the reason they are so important is because we are storing more and more raw data or unstructured data into our databases, right? Long text, JSON and other unstructured data. And a way to actually execute meaningful searches on top of this data usually is to pass them through some of the learning models like large LLM models or other deep learning models in order to get a numerical description of the unstructured data that you get that you have loaded into the database. Only at that point you can actually run some meaningful searches over there, and typically those are going to be similarity searches that we are using in generative AI applications regularly. And vectors are at the foundation of scenarios like building recommendation engines or recommendation features for our, say, e-commerce apps, or question answering tools and bots to interact with our data with like natural language, or building retrieval augmented generation applications, again passing vectors to our models, right? So in Azure Database for Postgres, we do offer native vector search capabilities through our famous open source extension called pgvector. And this extension basically creates a new data type for our databases, new indexes and new functions to run these similarity searches, right? And the goal here is you can take your own OLTP application with your data stored in Postgres and augment these data with new vector data that will get generated by a given kind of external service, or as we will see, a different extension. And from there, you can actually run your similarity search queries and get meaningful data out of your own kind of relational data. The pgvector actually does also, as I was saying, provide two different index families. the IVF flat, which is more like a clustering mechanism to apply k-means clustering. These indexes are very memory efficient, but they are like read-only, meaning that you create the index on top of your data, and they will not get maintained if your underlying data are changing. You actually need to rebuild your indexes every time. Or the other family is HNSW, which is a multi-layer graph type of index. This does support data to be changed, underlying data to be changed, because the graph will be kind of incrementally updated over time. So let's take a look. I have a very quick demo here, which is showing you how we can actually use those extensions. I mentioned, let me actually show you. Okay, here's my database. Okay, so I'm showing you the list of installed extensions for my own kind of database. And we can see the vector extension that I was mentioning previously, right, which is storing, exposing the vector data type and the indexes. But I also have installed my Azure AI extension, which is basically integrating Azure AI and ML services with my Postgres, right? So I'm going to show you a quick demo where I previously actually, this is the kind of setup required in order to point your local database to the Azure OpenAI extension, OpenAI endpoints that I just created with its own subscription key. Same for the Azure Cognitive Services or language services out there called today. And I do have here a table, which is called My Recipes, with a certain kind of structure over here. Recipe ID, the title, the ingredients, the instructions or directions, and a bunch of other data points, right? So if we look at, let me show you, this is how my data looks like. So I have a bunch of, recipes here with, again, ingredients and some other data points. And I do already have an embeddings column here that I previously created, but I'm going to show you how, I did it. Because let's say when we are doing searches on unstructured data, we can use capabilities like, for example, the SQL function like or I like. And if we are looking for a certain recipe which contains the word avocado in its title, we can actually run straight this topic here. And this is a pretty inefficient way of searching for a portion of a text. Typically, this is actually causing a table scan behind the scenes because the query processor cannot know exactly where that particular word or fragment of a word is positioned, right? But still, is giving us the ability to search on textual data some arbitrary words. But what if we are doing actually some more semantic search, like, hey, give me back all my recipes where they contain some kind of high protein recipes. And of course, this is not going to work, right? Because I like is going to search for this particular words and will not be able to find it because it cannot interpret what is in that particular recipe. So, starting point is actually to take all my textual data and informations and, to join them together. Now we have, a large text here. And we want basically to transform this text into numbers, right? And what we do here is actually to invoke our OpenAI extension here and call a function called create embeddings. So this is basically passing my text, as you can see here, and is passing to my OpenAI model where I have deployed text embedding ADA to a large language model where, it's through this function, I'm going to pass the data and we get back, as we can see here, we get back a vector, right? So this is basically a collection of real numbers, right, that are describing in a vectorized manner the text that I'm passing to my database. Okay, so what I did previously to save some time was to actually alter my table and add a new column of the vector type with 1536 vector count dimensions here. And I just used a default to update, so to create for each row basically the same embeddings column that I was mentioning previously, right? So once I have created this new column, now I can also create my different indexes to enable, to let's say optimize the different research functions, the different research paths that I have. Like, for example, I'm gonna go, a cosine distance analysis, or Euclidean distance, and so on. And once I have, my indexes in place, I can actually run queries like this. Like, for example, give me my, columns from my table, order by this, for my table, for my column embeddings, with Euclidean distance, ordered by actually the minor Euclidean distance between this sentence here that I'm sending and the data contained in my embeddings table. All right, so when I'm doing this, let me execute my query. He's giving back like 10, the top 10 recipes here that are closely matching the sentence that I'm passing here, right? So those are the ones that we can actually change. We can say something like a salty recipe for breakfast, for example, breakfast. Okay, and if we run the query again, we can see that, okay, now we do have a bunch of different options, right, that are, matching the request that I was doing here. I can also add, like, for example, with X, right, and because I like it. And if I search for this, you can see that, my responses are all of them in the ingredients column are reporting, eggs. And if we expand this a little bit, we will see. Yeah, to eggs and so on and so forth. So what we're doing here is basically we are passing query here in natural language, some semantic query. We are getting back a vectorized kind of version of this sentence from our OpenAI service, and then we are actually using our local vector, PG vector capabilities to do search, semantic search on top of our kind of vectorized data stored in the table. So this is just one of the common patterns that we are using in AI. Just to give you an example of what is possible here, like, for example, we can take use a different function here, like this summarized abstractive, where we're going to take our directions the column here, which is explaining how to actually cook, prepare and cook your recipe. We are passing this to this particular function, and we will receive back. Let me show you for this particular recipe here. Here we go. We are basically receiving back an abstract in textual kind of description of all the steps required to create your recipe here, right? So this is another different service. These are our Azure cognitive or language services, but same approach where you can pass your relational data into the external service, get back a response and reply back to your application. A different type of capability. Here we are using a language translation, for example. So we are taking our instructions for preparing a certain recipe and we are translating it in Italian this time, right? And if I run the same query, you can see that all the directions here now are in Italian. Trust me, these are Italian. Okay.
I just want to mention something that I really love of this solution is that you don't have to write programs like, for example, using JavaScript or Java or whatever. You are doing all this from the database, which is pretty fantastic. So.
Yeah, that is totally correct, Ismail. So, or the other option, the other alternative to this would be to have your code running somewhere to invoke Azure OpenAI services independently, and then maybe save back the data into the database, which is going to be more kind of cumbersome at the end of the day, right?
Yeah, and this is especially good for migrations, no? If you already have the database with the data, it's just a script away from the real deal. So
totally, yeah. So we just actually announced another unique capability in this space for Azure, which is the new kind of type of indexing, the disk INN. So this is basically a result of a collaboration with Microsoft Research to create a new generation of indexes, which is going to be more accurate and more also performant for data that will get updated frequently in your database. Right, it's superior to the existing indexing mechanisms because it is providing this higher accuracy, but at the same time is also reducing the amount of memory footprint required because a portion of those index will get basically saved into disk for being more basically for diminishing the amount of RAM used. And then would basically be reloaded when it's needed. And there's also the ability to execute a vector compression, so taking large vectors and compress it again to reduce both in memory and on disk size. But the accuracy point is super important because unfortunately, when you have an index like HNSW, the more you are actually deleting, inserting, updating the data, you can see this on the chart, based on the number of insertions for the same data, the index quality will actually get degraded, right? So you will get less precise results out of your queries. And, the only option that you have at that point is just to rebuild the index once more, which will cause probably application downtime and more resource utilization on your database and so on. While with disk INN, you can see those other lines above. You can, depending on the size of the list of elements that you are indexing, you can actually get a pretty large and a pretty high accuracy of your data. So this is a perfect match for OLTP, real OLTP workloads that are actually changing your data frequently in your index, vector tables and columns. Okay, so I mentioned already the integration using the Azure AI extension. Which is again providing this SQL-based approach to communicate behind the scenes with our Azure AI services. It does support, as I was mentioning, Azure OpenAI, but also language services, machine learning, and so on. So you can use and access those services from within your code. Sometimes when you have a lot of embeddings to create, what can happen is that reaching out an external service can be very expensive. So we actually introduced a local model, local large language model, which is based on the open source A5 embedding model version that we actually published as open source from Microsoft, and you can actually use that locally to your database instead of reaching out an external service. This is basically giving you like 10 times faster creation time for new embeddings for those models for those use cases where you have a lot of newly generated data that you need to actually index and create vectors for. This is definitely a great solution because it's basically it doesn't require you to reach out to something like an Azure AI, Azure OpenAI endpoint. It can do all in your database. And also from a security perspective, again, you don't need to send your data anywhere. You can do all within your database. And you can see the difference here, like the remote embedding version, you are basically calling our Azure OpenAI and invoke the create embedding. And this is in the backend reaching out Azure OpenAI models. For the in-database embedding model or local, actually the API is exactly the same. It's a different function here. But at that point, you don't need to reach out to any external service. You will create your vectors within the database.
I have one question, Silvano. This, I mean, since this uses like an LLM kind of things, do you have to pay more, like put a GPU or something with the database? Or
no, absolutely. Of course, this is going to use local resources, so your database sizing and so on needs to consider the fact that you are leveraging more local resources in terms of memory size and so on. As an example, we recommend to use memory optimized SKUs and service tier, but per se is not going to cost you anything.
Okay, thank you.
Okay, Copilot, as I was mentioning, we know it very well. We know Copilot is pretty much everywhere, and we are actually introducing Copilot based interface for managing and running your Postgres flexible servers in Azure. Right? So you will be able to, for example, figure out why, for example, a given server is slow responding to queries, or any other management operations will be available through Copilot in addition to the regular APIs. Right? So this is just basically helping developers and DBAs to do their job in a better way, assisted by our AI Copilot. And this is of course trained with our own kind of infrastructure models. So it's providing more accurate responses for customers that have questions on how to run their Postgres services more efficiently. Okay, so we were talking about Fabric at the beginning. So we have two scenarios here where we are helping customers to integrate their Postgres data in Fabric. So first of all, we are announcing our Fabric mirroring capabilities for Postgres in Azure, right? And you can find a private preview form to submit your candidature for this service. What is mirroring doing is basically taking your Postgres data, and in the simplest way possible is mirroring, is replicating the data into one lake, into Fabric one lake, using a delta table format, right? So that you can run all your analytical workloads from data warehousing, data engineering. You can run your Spark workloads on your Fabric data and not impacting your source OLTP databases, operational databases. This is also free, right? So the whole replication process and the storage size, so storage space in one lake is actually free up to the level of Fabric capacity that you have available. Like for example, there are several Fabric capacity levels that you can buy. If you buy, for example, the F64, it will give you up to 64 terabytes of storage cost for free to mirror your databases from Postgres and other relational databases into Fabric. But what is more important, there's absolutely zero effort in terms of building your ETL pipelines and such. Data will get replicated in real time from your operational data to your kind of analytical platform in Fabric. Right? And the way it's doing is basically capturing all the changes, incremental changes, and the initial snapshot from your source, and it's pushing the data into the OneLake storage so that the data are ready for the different workloads on Fabric to manage and to access the data. And I can show you in few seconds. I have here a mirrored database that I created a few seconds ago. This mirrored database is essentially a copy. I can show you, the interface here where I can. Here we go. So I have my source database, which is in a Postgres database in Azure, right? And this is my list of tables that I decided to replicate, and the status of my replication engine, and the number of rows and so on. And once the data is actually landed into Postgres, I can run my kind of analytical queries here, and I can see I have my sales schema, which is the one that I created, and I have the same tables that I was kind of loading on the Postgres side, and I can start running my own kind of analytical queries, and like for example, link my queries from Postgres to other databases that I may have mirrored in Fabric, do cross database queries and aggregations and so on. So this is the simplest way to actually mirror all your data on Fabric. The second option that we have is to actually use data streaming, so capture using CDC, change data capture, all the data changes on our source database, and propagate them into our real-time intelligence platform in Fabric, so that you can take actions, right? So you can analyze the data in flight. Like, for example, I have a new record which gets inserted in my database. I want to see if that record is actually showing some interesting characteristics, like high number of orders or such, and take actually actions in real time. So what again the real-time intelligence platform is giving me is the ability to ingest through event ingestions my data changes into Fabric. And again, I have a quick example here where, let me show you the diagram. So I can just point to my source database in Postgres, and my new event stream will get loaded by all the data changes, where I can at the point, like for example, filter and say, hey, only the quantity of my orders that are greater than 10,000, just take these 3 fields and land them into my lakehouse. So this is just an example. Or I could have a different action here, like triggering a certain function, or for example, a certain process to take that order and do something, right? And I can quickly show you. This is the payload of my event that has been captured a few minutes ago, and I have my data information. See my sales table, which is order details, and I can get all the information regarding my record changes in the database and do something in my analytical platform. Okay, so this is essentially the ability to pipe treat your data changes as a stream of information that you can process in real time in Fabric. Okay, so I just we are reaching the end of the presentation. So this is a list of resources where you can get more information regarding Azure Database for Postgres. You can get a lot of samples and information and blog posts and so on. Feel free to also ask our team for whatever information. This Ask Azure PostgreSQL at Microsoft.com is basically our own kind of mailbox where we keep up with customer requests. And we also have a public forum where you can, again, ask questions or ask for specific kind of new feature requests, and so on, which is aka.microsoft/pgfeedback. Okay. I think if you have specific questions, let me know. We are here to kind of answer your questions for the last kind of few minutes of this presentation. Did you find any question in the chat, Ismail?
Sorry, I was in mute.
Yeah,
No,
no
I was just saying that no, there are no questions at the moment. We have someone answering the questions, so but we can still go. I just want to mention that in the previous slide there was this link when you can go and try Azure database for PostgreSQL for free for 1 year, and this is quite important also in the context of this hackathon. No? If you want to play with it for the first time, well, you just have to go to that link. And well, I'm gonna probably continue with just the announcements of the sessions. Well, we are just remember also that you can try Fabric for free for 60 days now with a pretty performant capability and F64, so it's quite good. You have up to 1 terabyte of one lake storage, so you can really mirror a full database. Well, right now it's in private preview, but soon it can you could mirror also your data easily. But well, for the context of the hackathon, also you can play with it. I also want to mention that, well, we have created this Azure AI, OpenAI proxy that you can play with it so you don't have to pay in the context of the hackathon. You can use this to do the things you need to do to the experiments or your trials. And also, well, I just want to mention quickly that, well, we're 1 week from the end of this, so remember that we have the different criteria to judge the prices of the hackathon. Well, there are different categories, of course, and well, remember we have the grand prize that is for the overall good idea that you have, but we have other prizes, and well, sorry. Okay. And well, we have this AI innovation prize, but more important for the context of today, we have a prize for the best integration you have of Azure database for PostgreSQL. So if you're already playing with it, you can use all the things you saw in today's presentation and well, integrate them with even if you don't use, I don't know, CDC or this kind of live stream kind of integration, but you do it yourself on your own. That's something that could be cool to see how you land this data in Fabric. How do you get things done for an AI scenario on your own? So don't hesitate to participate in this category. And well, with that, well, there are the other categories that you already seen. Well, the SQL and AI, the Cosmos DB also for the case. So the last announcements for today. Well, remember, if you haven't joined, we have the Fabric community. You can join there and discuss with all the other people using Fabric, and obviously give us feedback for the products and in general. You can also go to the specific forum for this Fabric Hack Together chat. So you can ask questions with other participants and interact. But more recently, also, we have noticed that some people prefer to use Discord for these things. So we also set up a Discord for this that you also can find in the link. So you can go ahead and well, ask your questions there. There's still 1 week to go, and I suppose this is the period where everybody's going to crunch to finish all the projects you are building. And finally, well, all of these, obviously, all this project in the hackathon, all these courses of the skills challenge, all these things are to learn, and well, in the end, this learning is with the goal of building your career so you can learn more and both get more skills and prepare yourself for the certifications on Fabric and on other data products. And of course, well, we have this website where you can learn more and get some guidance on how to grow in your data and AI career. So yeah. Last thing well, this is the end of today's presentation. Tomorrow we will have a presentation about Fabric's data warehouse. So don't hesitate to join us tomorrow. And well, I think that's all for today. Thanks a lot, Silvano, for joining us today.
My pleasure.
And well, see you soon, everyone.
Thanks, folks.
Yeah.